2,000 years ago, most cities across the globe struggled to house 20,000 people. At its absolute peak, Rome supported over 1 million. Keeping a population of that size alive required feats of engineering no civilization had ever attempted. The Romans developed strict systems of civil law, pumped massive volumes of running water across valleys, and constructed complex, multi-story apartment blocks. But dense infrastructure is highly fragile. In 64 AD, a massive fire broke out, tearing through the crowded streets for 6 straight days and reducing much of that carefully engineered city to ash. Instead of rebuilding housing for the displaced citizens, Emperor Nero seized the devastated land. He cleared an estimated 300 acres right in the heart of the capital to construct the Domus Aurea, his own lavish private palace and artificial lake. Using the state's vast resources strictly for his own luxury enraged the public and the army. An empire built to manage 1 million people could simply not survive if its engineering only served a single man. The public fury over Nero's greed eventually drove him from power, and he took his own life in 68 AD. His death triggered a massive power vacuum, throwing Rome into a chaotic cycle of military revolts. When a military commander named Vespasian finally secured control of the state, he made a calculated political decision. He ordered Nero's sprawling private estate to be systematically torn down. Right over the footprint of the tyrant's artificial lake, Vespasian began construction on an enormous public arena. Today, we know it as the Colosseum. The new Flavian dynasty understood that to hold on to power, they had to give the city back to its people. Public engineering became a vital tool of statecraft, used directly to keep the population entertained and loyal to the government. By 80 AD, the Flavian amphitheater officially opened. Sitting where Nero's estate once stood, the sheer physical mass of the structure dominated the Roman skyline. The arena could hold up to 80,000 spectators at a time. Filtering that many highly emotional, densely packed citizens in and out of a single space safely was an absolute logistical nightmare. This diagram shows the engineering breakthrough that solved the problem: the concrete arch. Instead of a flat beam that breaks under heavy pressure, the curved shape forces immense weight outward and down the pillars. By multiplying these arches and stacking them, builders achieved immense vertical height without the walls collapsing under their own weight. The resulting structure was a highly calibrated political machine. It efficiently processed tens of thousands of citizens, delivering elaborate public spectacles that maintained order in a deeply volatile metropolis. By the early 2nd century AD, Emperor Trajan had pushed the borders outward, conquering new territories until the Roman Empire covered roughly 5 million square kilometers. Trajan marked his military victories with vertical monuments, like this 30-meter-tall marble column carved with a continuous spiral of his campaigns. But his most effective engineering legacy was built directly on the ground. A government based in Italy now had to figure out how to physically control, resupply, and communicate with millions of subjects, spread across Europe, North Africa, and the Middle East. This map illustrates their solution. The state systematically constructed over 400,000 kilometers of standardized, highly durable stone roads. These continuous routes act as the physical arteries of the empire. They allowed legions to march quickly to distant frontiers and merchants to move goods easily, tying a fractured map of conquered tribes into a cohesive, hyper-connected global economy. Trajan's successor, Hadrian, shifted focus away from rapid military expansion. Instead, he concentrated his efforts on pushing the absolute physical limits of Roman material science. Completed around 125 AD, the Pantheon was designed as a temple to honor all the gods and serve the public's spiritual life. Nearly 2 millennia later, it remains the largest unreinforced concrete dome on Earth, built entirely without internal steel supports. At the exact center of the ceiling is a circular opening called the Oculus. This distinct feature acts as the building's only source of natural light, greatly reduces the crushing physical weight of the dome, and allows rain to fall straight through to a specialized drainage floor below. The Pantheon represents the exact moment Roman material science achieved structural perfection. Engineered so accurately, it has survived 19 centuries without requiring any major structural alteration. No political system lasts forever. In 476 AD, the Western Roman Empire formally collapsed. The last emperor surrendered, and the political structure of the ancient world died. While the government fell apart, the physical city did not. The infrastructure left behind was far too massive and too meticulously constructed to easily disappear. By pivoting their vast resources away from the private vanity of tyrants, Roman leaders engineered a network of roads, arenas, and temples designed strictly to connect and sustain massive populations. They left behind a physical foundation that modern civilization is literally still walking on today. If you enjoyed this look at ancient engineering, please like the video and subscribe to the channel. And let us know in the comments below, which Roman architectural marvel do you find the most impressive?